Welcome to Maker Store. This is Maker STEM, our educational series where we explore engineering, electronics, programming, and digital fabrication through hands-on projects. In each project, we combine creativity with technology to build, learn, and inspire the next generation of makers. In this STEM project, we'll show you how to control addressable LED rings using an ESP32 microcontroller. By combining simple electronics with programming, we can create custom LED displays, lighting effects, and interactive projects. By the end of this tutorial, you'll learn how to wire your LED ring, upload the code, and create your own programmable lighting effects. For this project, we're using several key components: an ESP32 development board, an ESP32 breakout board, and an addressable LED ring, wires and cables for connecting the LED module, and a USB-A to micro USB cable for programming the controller. All of these components are available from Maker Store. Before connecting the LED ring to the ESP32, we first need to prepare the wires. Start by stripping the ends of the wires to expose the metal conductors. Once the wire is stripped, gently twist the exposed wire strands together. This keeps the strands neat and prevents them from fraying, making them much easier to solder. Next, set up your workspace with a helping hands tool to securely hold the LED ring while you work. You'll also need a soldering iron to melt the solder and create electrical connections, a solder smoke absorber to remove fumes produced during soldering, flux to help the solder flow smoothly and create stronger joints, the 3 prepared wires, and an addressable LED ring. Apply a small amount of flux to the solder pads on the LED ring and the ends of the wires. Flux helps the solder flow more easily. Using the soldering iron, first apply a small amount of solder to each pad. This process is called tinning, and it prepares the pads for an easier solder joint. Next, place the prepared wire onto the tinned pad. Gently touch the joint with the soldering iron until the solder melts and flows around the wire. Once the solder fully surrounds the exposed wire strands, remove the soldering iron and allow the joint to cool naturally. A good solder joint should be smooth, shiny, and securely hold the wire in place. Repeat this process for the power, ground, and data connections. Now that the LED ring has been soldered, we can prepare the other ends of the wires for the ESP32 breakout board. Crimp wire ferrules onto the ends of the 3 wires. Ferrules keep the wire strands neatly together and provide a stronger, more reliable connection when secured inside the breakout board terminals. Now we're ready to connect everything together. Before making any connections, notice that each terminal on the breakout board is labeled to match a pin on the ESP32. Although the screw terminals are positioned around the outside of the board, each one is electrically connected to the ESP32 pin with the same label. Using the terminal screws on the breakout board, connect the 5-volt wire to the terminal labeled 5 volts. This supplies power from the ESP32 to the LED ring. Next, connect the ground wire to the terminal labeled GND. Ground completes the electrical circuit, allowing current to flow properly between the ESP32 and the LED ring. Finally, connect the data wire to GPIO 15. Unlike the power and ground connections, the data wire carries the control signals that tell the LEDs what colors and lighting effects to display. GPIO stands for General Purpose Input Output. These numbered pins allow the ESP32 to communicate with external components such as LEDs, sensors, and motors. You can identify each GPIO by the number printed on the board or by referring to the DevKit C pinout diagram on the Maker Store website. For this project, we're using GPIO 15 because it matches the example code in our tutorial. If you decide to use a different GPIO pin, simply update the pin number in the code to match your wiring. Before uploading the program, we first need to install the required software and libraries. If this is your first time using an ESP32, open the Arduino IDE, go to the Boards Manager, search for ESP32, and install the latest board package. Next, open the Library Manager, search for Adafruit NeoPixel, and install the latest version of the library. Next, we need to tell Arduino which controller we're using. Open the Tools menu, select Board, then choose your ESP32 development board from the list. If you're using the same controller as this tutorial, select ESP32 Dev Module. Now connect your ESP32 to your computer using a USB cable. You can then copy the complete code directly from our tutorial article. The link is provided below this video. If you are using a different size LED ring, remember to update the number of LEDs in the code. Choose the correct COM port and upload the code. When the upload is complete, your LED ring should immediately begin displaying the programmed lighting effect. Congratulations, you've successfully completed this Maker STEM project. If you'd like to learn more, be sure to check out the project article linked below this video. It includes the wiring diagram, library setup, example code, and additional resources to help you get the most out of this project. All the components used in this build are available from MakerStore. Thanks for watching, and we'll see you in the next Maker STEM project.